exponent rule. It's kind of a rule I set aside from 304 because it may be new for you. Do you want the lights off? Is that better? So before, you've never had a fraction up in the exponent. I hope this wasn't on your SAT. So you would have known how to do it. Can I mark that with you? What? Okay, so you've never had a denominator before. So the denominator is creating the index of a radical. So a denominator, fractional exponent, creates a radical. So in other words, a fractional exponent means you find the nth root of the expression and then you raise it to the nth power at the end. So if you think about the other ones that you've had to evaluate, like 8 squared, you've done 8 squared before. That means that you've done 8 to the 2 over 1 power. It's always been over 1. So now your denominator is not just 1 anymore, right? Because 8 squared is just 64. I didn't have to take any radical because it was a 1. So now if I have a 25 here, it's the 1/2 power. It's not multiplying by a half. It's raising it to the 1/2 power. So the radical is going to be the 25 square rooted. And then the first power, because that's the numerator, is the power. And the square root of 25 is how much? 5. And 5 to the first power is just 5. So writing 25 to the 1/2 power just means taking the square root of 5. 25 raised to the 1/2 power on my calculator. See how it comes out as 5? So an exponent power makes it a radical like that. So this one is 16 to the 3/2 power. So you're going to put the 2 outside the radical, and you're going to do that first. And then at the end, you're going to cube it. Because you don't know what 16 cubed is in your head. That would be too big to do without a calculator. What is the square root of 16? So what times what is 16? 4. So I really am going to do 4 cubed because I can do 4 cubed without a calculator. 4 times 4 is 16 times 4 is 64. Maybe you don't know that one without a calculator. I don't know. You know that 4 cubed is 64? Oh. Well, how is that? I've never played. Okay. All right, so number 3. What's going to go for the index? What goes out here? This is the 27. The 3 goes out here. I don't know 27 squared in my head, so I want to do the cube root of 27 first, which is, so what times what times what would give you 27? Is it 2 times 2 times 2, 3 times 3 times 3? Right, 3. So then I'm doing 3 squared, and 3 squared is 9. So see how you need to know the powers of 3, the powers of 4, the powers of 5? You need to know the cube root of the number. All right, you try 4, 5, and 6 for a minute, but you might want to wait and we'll do 7, 8, and 9 together. Try the 4, 5, 6 row. See if you can set it up with a radical. So if it's 5 of the same number, right? Something times something times something. It has to be a pretty small number. Yeah. The 5th root of 32 is 2. Does it be 2 times 2 times 2 times 2? What would it be? That is the hack. The hack is rewriting it as a radical. That is the hack. So you could do it without a calculator. So right, this one becomes 2 squared, which is 4, right? So the answer to number 4 should have been 4. I heard Spencer say it. You said the answer already to number 5, didn't you? So you're taking the square root of 49 and then raising the answer to the first power. So what is the square root of 49? Just 7. So 7 to the first power is just 7. So raising a number to the half power, just like we did in number 1, it's just taking the square root of that number. I don't know who thought this up or who thought fractional exponents would be a good idea, but someone did. Or how they figured out that a fractional exponent is the square root of a number, I don't know. I don't know like the theory behind that. And then number 6, you're taking the square root of 9 and then cubing the result, because you don't know 9 cubed, so you don't want to do that one first. Order of operations, you could do either of these first. But logic-wise, I know the square root of 9, right? The square root of 9 is just what, Aubrey? Okay, so you're getting down to number 7. I'm going to do that one in a second. This one came out to what? 3 cubed was 27. So there are two distinctions to make. Can I take the square root of a negative number? I take the square root of negative 49. Okay. Is negative 7 times negative 7 negative 49? Okay, it has to get you back to the same number. So that's why there's no solution when you take the square root or an even root. But what if I want to take a cube root of a negative number? Can I do it? It's going to be negative 3 because isn't negative 3 times negative 3 times negative 3 going to give you back negative 27? So if you have an odd root, you can do it with a negative, but if you have an even root, it's going to be no solution with a negative. So there's 2 negatives in number 7, though. There's a negative on the 27, and there's also a negative on the exponent. What does a negative exponent do? That does something different. That makes it a reciprocal at the end. So my first step is I'm going to take the cube root of negative 27, and then at the end, the negative 1 power takes the reciprocal. So we just said the cube root of negative 27 is negative 3, and I'm taking the reciprocal of negative 3. So I get negative 1/3. It's still negative. Nope, a reciprocal stays like negative or positive. So if you had the reciprocal of 4, it's 1/4. But if you had the reciprocal of negative 2/3, it would be negative 3/2. So it doesn't change the opposite sign, it just flips the fraction over. Nope, 8 has a positive 4 that's under the radical. So you can do anything you want to a positive number. You're taking the square root of 4, and then at the end, you're going to raise it to the negative 3rd power. So what is the square root of 4? 2. And then I'm taking 2 and raising it to the negative 3rd power. So I'm doing 2 cubed and taking the reciprocal. Yeah, so 1/8, but it's positive 1/8. All right, see if you can work through the rest of those, 9 through 15. See which ones you can do or can't do. See if you can simplify them. And this is a challenging rule. If you've never ever seen this before, it's like, whoa, new math. So we got 0, 1/8, 10, 24, 4. Because you get negative 5 that you're squaring, negative 5 times negative 5 is positive 25 on that one. Did you put it in parentheses? See how the negative 125 is in parentheses right here? If you put it in parentheses, I think it should work, and you'll get positive 25 as your answer. Oh, okay. Put it in parentheses. Okay, so that's the fractional exponent rule. Part 2, on the back page 306, and then you're going to try some guided practice on this. This is just solving for the variable, and these are all powers that should be kind of mental math. So you're able to solve these without needing a log or an inverse. For example, number 1, x has to be how much? 3, because we know that 2 cubed is 8. So I'd like you to try 1 through 6 using mental math, and then in the bottom, we may need to do a little bit of work together because not all of them are mental math in the bottom. But try those first 6. It should just be like, okay, I know that power, I know that power. You're actually solving exponential equations. Yep. Yes, it is. Did you have time to try those? You're almost done. He's like, I don't have enough room up there. Well, I don't see why does he not play in the turtle water? It's gross. Okay. 3 squared is 9. 5 cubed is 125. 6 to the 0 power is 1. 10 to the first is 10. And 5 to the 6th is 5 to the 6th. So those should be like quick mental math problems. The ones on the bottom certainly get more challenging. You might be able to do that in your head, but you might need to think it through when you get down to 10, 11, and 12. I think you could do number 7 in your head. When you think about the table, what power do I use to get to 1 over 9? So I got to flip it over, and I have to get to 9. So what would the power have to be for number 7? -2, right. So the negative is what gets you your reciprocal. So same thing for number 8. You might want to check it on a calculator. What power of 4 is 256? I think it's 4th, isn't it? 4 raised to the 4th is 256. So it would be the -4th power because I want to flip it over at the end to make it 1 over 256. And number 9 is also getting flipped over, right? It's currently 1/4 and you want to get to 16. What power? It's negative power. And 4 squared is 16. So it'd be just the -2nd power to get to 16, right? Because you're exponent. So when you get to something like 10, I think you could still do 10 in your head. You need this to be 7 squared, right? What does x have to be? X would just have to be 1, right? So that 2 times 1 is still 2. All right, what power of 3 do you need on number 11? 3 to what power is 81? Well, but you need it to be 4 because 3 to the 4th power is 81. So what does x have to be to make it true? 2 times 2. X has to be 2. So the last one, number 12, that she has like the worst. Every year. Abrams. They're always animals. Seriously, I don't know. It's like she's a saint. Okay, 5. 1 over 5 equals 25 to the x power. So if you start by at least writing this, yeah, it wouldn't be -5. You want to take 5 and get to 25. So what power do you need? Or sorry, actually, you need to take 25 and raise it to the x power to get down to 1/5. You're actually going backwards, right? This one we might need, okay, here's another strategy. I don't like this strategy. So let's leave 5 as the -1st power. How can I rewrite 25 using a base of 5? 5 squared, right? Have I changed the value of this side of the equation? I still have 25 raised to the x power. What is the rule for when you distribute an exponent? Multiply. So I can rewrite this as 5 to the -1st, that side hasn't changed, equals 5 to the 2x power. This is called the one-to-one property. We'll see it more a little bit next unit, but if the 5 is the same on both sides, guess what? The exponent also has to be the same. So if -1 equals 2x, what does x have to be? Divide by 2 on both sides, and x has to be -1/2. So how does that make sense? If you take 25 and you take it to the 1/2 power, isn't that 5? Because we just talked about fractional exponents, right, or square roots. So -1/2 is the answer? Yes? Okay, so there is a guided practice that I guess you'll have time to do in class. I don't know if we'll get to the